Hello, in this lecture, we will discuss measures of center. Descriptive measures that indicate whether the central or most typical value of a dataset lies are called measures of central tendency, or simply measures of center. The most common measures of center include mean, median, and mode, where mean and median are applicable for only quantitative data, but mode is applicable for both quantitative and qualitative data. Before we move on, I want to introduce some notations. When presenting a formula, we usually assume that the data are x1, x2, x3, and up to xn. We use letters with subscripts to indicate numbers in a dataset, where x1 means the first number, x2 means the second number, and so on. Xn is the last number. The n indicates how many numbers in the dataset. We call n the sample size. If mean, median, and mode are calculated from a sample, we may also call them sample mean, sample median, or sample mode. The mean of a dataset is the sum of observations divided by the sample size. We use the notation x bar to denote the sample mean, where x bar is just the letter x with a small horizontal line above it. The displayed formula explains how the mean is calculated. We first calculate the sum of all observations and then divide it by the sample size n. Look at this example. The data contains the weekly salaries of 13 employees in a small firm. To calculate the mean salary, we first calculate the sum of all numbers, which is 6,290. Then divide the sum by 13, because we have 13 numbers in the dataset. The mean salary is therefore $483.85. The median is the number that divides the bottom 50% of data from the top 50%, or roughly half of the data is smaller than this number, and the remaining half of the data is larger than this number. In order to calculate the median, we first need to arrange the data in increasing order. The median is at position n plus 1 over 2 in the ordered list. What does it mean? If the sample size n is an odd number, the median is the observation exactly in the middle of the ordered list. If the sample size n is an even number, then the median is the mean of the two middle observations in the ordered list. Let's look at two examples. In the first example, the data contain weekly salaries of 13 employees in a small firm. The sample size is 13, and it's an odd number. Therefore, the median is exactly the seventh number in the list. Notice that the data has already been sorted. The seventh number is 400, which is highlighted in blue color. So the median salary is $400. In the second example, the sample size is 10, and it is an even number. So the median is the mean of the two middle observations. The data has already been sorted. The two middle observations are the fifth and the sixth numbers in the list, which are 300 and 400. Therefore, the median is their average, which is 350. So the median salary is 350 in this dataset. Make sure to sort your data before finding the median. In these two examples, the numbers have been sorted already, so we directly find the median. If the numbers are not sorted, we need to sort the data first. The mode is the most frequent value in a dataset. In order to find the mode, we first need to find the frequency of each value in the dataset. If no value occurs more than once, then the data has no mode. In this case, all values are different from the remaining values. Otherwise, any value that occurs with the greatest frequency is a mode. Look at this example. There are weekly salaries of 13 employees in a small firm. We can see that 300 is the largest frequency. It appears 6 times. So the mode for this dataset is 300. Sometimes a dataset may have more than one mode. In this example, we have 13 observations. Notice that both 300 and 400 appear 4 times. The remaining values appear less than 4 times. Therefore, the modes are 300 and 400, both with frequency 4. We have 2 modes in this example. Usually, mean, median, and mode are different in a dataset. We want to emphasize the relationship between mean and median for symmetric and skewed distribution. Look at the graph in the middle first. The distribution is symmetric, and the median is equal to the mean. When the distribution is skewed, mean and median are usually unequal. For a right-skewed distribution, the median is smaller than the mean. For a left-skewed distribution, the median is larger than the mean. Therefore, by comparing the mean and median, we may have a rough idea about the skewness of the distribution of the data. If the mean and the median are close to each other, the distribution is roughly symmetric. If the median is much larger than the mean, the distribution is left-skewed. If the median is much smaller than the mean, the distribution is right-skewed. Based on the 2018 American Community Survey, Alabama median household income is $48,486, and the mean household income is $67,243. What is likely the shape of the distribution of household income in Alabama? Because the mean is much larger than the median, the distribution is likely to be right-skewed. Resistance measure is a concept that can help us understand the difference between mean and median. A resistant measure is not sensitive to the influence of a few extreme observations. Median is resistant, but mean is not. Look at the table. Each row contains one dataset of 5 numbers. The first 4 numbers are the same, and the only difference is the last number. It is 88 in the first dataset, and it is 0 in the second dataset. If we calculate mean and median for these 2 datasets, we will find that the mean is quite different. The first one is 88.4, and the second one is 70.8. However, the median does not change much. The first one is 88, and the second one is 86. This example illustrates that a few extreme observations does not affect much the value of the median, because the median is only determined by the number in the middle. We may improve the resistance of mean by using a trimmed mean. To compute a trimmed mean, we will first remove a percentage of the smallest and largest observations, and then use the remaining numbers to compute the mean. Such a way of computing a mean is common in reality. For example, in gymnastics, there are usually several judges. When calculating the final score, the highest and the lowest scores will be dropped before calculating the average. In this example, we remove the largest and the smallest numbers before calculating the mean. The trimmed mean is 88 for the first dataset, and it is 86.3 in the second dataset. They are close to each other. The table lists some Excel functions for common numerical descriptions. Assume that the data range is A1 to A15. To calculate mean, we use the function average. It has only one argument, the data range. To calculate median, we use the function median. To calculate mode, we use the function mode. To calculate trimmed mean, we use the function trim mean. The function trim mean has two arguments. The second argument indicates the percentage of data to be dropped. For example, here we have 0.2. It means that 20% of data will be dropped before calculating the mean. The 10% from the top and the 10% from the bottom will be dropped.